Hi guys, welcome to Combine Like Terms. Okay, we're starting 2.1. Do a quick video on a review of how to do combine like terms. Here we go. Okay, so combine like terms. So it's often to write algebraic expressions so that if we have the fewest number of terms possible, then it'll be simpler. So we can combine like terms, we call it, right? So like terms have the same variable, same exponent on that variable. So when we're talking about parts of an expression, we look at what the coefficient is, which is the number in front of your variable. This one is 5. This one in the middle, this coefficient is 10. And this one does not have a variable, so we just call it a constant. Okay? And then the variable is a letter. So this one's the x. This one's also an x. And we can tell that 5x and 10x are like terms since they both have just an x with the same exponent. Now, if we change this variable, let's say for the exponent, let's say it was x squared. Now, none of those would be like terms because none of them have an x squared. In order for them to have like terms, they have to have the same variable and the same exponent. So 5x squared and the 10x squared would now be like terms, and now we can combine them. Okay, so a quick little review definition. So variable is a symbol for a number that we don't know yet, usually an x or an y. You can use any letters, but usually the first ones you use are x and y. The coefficient is a number that tells us how many of those variables we have. Okay, so how many of those variables we have. 5x says we have 5 x's. Okay, 10x would tell us we have 10 x's. For this one, even if it has a variable, 5x squared tells us we have 5x squareds. 10x squared tells us we have 10x squareds. Okay, so keep that in mind. The coefficient, all it does is tells us how many of those we have, so that we can just add them up, like 5 dogs and 10 dogs. We just add them together, we get 15 dogs, right? Okay, constant is a number on its own without a variable. Yeah, just a lonely number is a constant. So that's your lonely number has no friends. So it's a constant out there. Okay, so this next example. So 2x plus 8 plus 3x minus 6. We can see that 2x and 3x have the same variable. So the first one has 2, the second one has 3. We just add them together. We have 5 x's, right? 5 x's. Then we go to the next one. We have 8 is a constant and negative 6 is a constant. So we combine those like terms and we get positive 2. So our simplification of that would just be 5x plus 2. Right? If they're not like terms, we don't mess with it. We don't mess with it. Now let's keep going. Okay, that was an example how to find it out. Let's go over this real quick. So if you want to see if it is correct, both of your expressions should be exactly the same, should be equal. And we're showing that by equal, if we substitute a number, they should come out the same, right? That means they're equal. So we substituted 10 into the first one for both our x's, x values. We have 20, 30, bring down everything, we have 52. On the right side, we still substitute 10, we get 50 plus 2 is still 52, so it works out. So both expressions are equivalent, which means they have the same value. So equivalent is like a fancy word for equal. They are the same value, but not exactly the same thing. You learn that geometry too. They're just equivalent. Okay, let's do some examples. Okay, so combine like terms to create an equivalent expression for each of the following. So we're going to look at which ones have the same variable, same exponent. So automatic, we can tell negative 6x and 19x have the same variable. Right? So we have negative 6 plus 19, and we just combine them, and we get negative 6 plus 19. What is that? 13, right? And then we have an x, just put x there, 13x. So we have 13 x's. And then we go to the constant. So you have 20 and 25, those two, and you just add them together, and we get 45. 45. Positive 45. So all this is 13x plus 45. So 13x's and 45 constants, or 45 numbers. Yeah. Then we go to example B. Same thing. We get what it has the same letters. So we get negative 7r and 6r. Those are both the same. We just combine them. We usually start with the letters first, and then put the numbers at the end on the right. So negative 7 plus 6 is negative 1. So we negative 1r. Then we go to the constants. So 14 and negative 6. Remember your signs, right? So it's 14. Remember the sign, negative 6. Same with your 7. 7 has a negative in front of it. 6 has a positive in front of it. So remember the signs, very important. Okay, so we look at negative, or 14 and negative 6 put together. 14 minus 6. Positive 8. And that would be our answer. So I'm just going to rewrite this. And so instead of negative 1r, we can just say it's negative r. It's the same exact thing. And then plus 8, bring it down to n. Okay, so same exact thing. Okay, next one. Now we have two different letters. So we got to be a little bit careful. Then we're going to do the alphabet, right? A, B, C, D, E, F, G, H. So G is before H. So we start with G. We usually go alphabetical order. So we have, I'm just going to circle it, 4G and negative G. Remember your sign. Then we combine that. So 4G and negative G. So this is like a negative 1G. So 4 minus 1 is 3. So 3 G's for my equal sign. Then we go to our next letter, which is H. Okay, let's do another color. So we have negative 5H and negative H. Remember the signs, right? So you have negative 5 and negative 1 here. Right? If there's no number, it's a 1. So negative 1H. So negative 5 and negative 1 put together is negative 6. Right? So you have negative 6 H's. Then we go to our constants. Negative 7 and positive 7. Negative 7 plus 7 is 0. Plus 0. So it cancels each other out. So we don't really have to write that, because 0 just disappears. So you get 3G minus 6H. It will be our simplified form. Okay, let's look at homework. Okay, multiple choice. Choose an equivalent. Remember that word? Equivalent is like equal. Equivalent expressions for A through Z, or A through C. So A, so look at which one is equivalent, right? So we got negative 6n, negative 2n. That should be negative 8n together. And negative 2 by itself, so it's negative 2. So we just look at which one is equal to this, negative 8n minus 2, which is A, right there. Part B, same thing, right? So we got 3x, and 2x, positive 2x, remember your signs. So 3x plus 2x, 5x. So we can tell, oh, C's out, D's out, right? Because that one doesn't have 5x. So it's either A or B. Then we go to our next number, 7 and 1, which gives us 8. So it has to be A, 5x plus 8. Okay, so I'll let you do C on your own. Okay, so let's do some problems on here. So we got, first one, 8y minus negative 8y. So remember, we have negative, double negatives is always going to turn plus positive. Okay, double negatives is always plus positive. So keep that in mind. So 8y plus 8y, we just add the numbers in front, the coefficients. 8 plus 8, 16. So you have 16 y's, right? 16 dogs, basically. So here's our answer, 16y. And let's go down. And we have 5x and positive x. And a third one, negative 9x. So now we have those three combined together. 5x plus 3 plus x minus 9x together. So 5x plus x, which is a 1x, right? So 5 plus 1 is 6. Minus 9 is negative 3. So we have negative 3x. And then by itself, we have the positive 7. So we've written down positive 7. And that's our answer. Negative 3x plus 7. And then j, do the same thing, right? So x first, so 4x, positive 4x put together. That's going to be 8 of them, so 8x. And then we go to our next numbers. So this one's our variable. So we have positive 2y and negative 5y. So positive 2 and negative 5 put together, negative 3, right? So negative 3, and those are called y's. So you have 8x minus 3y. Okay, so that's a little introduction. Combining like terms. Try it out. Khan Academy. Try that out. Try to get 100. Do your best. Do your best. Keep doing it. Practice. Keep trying. Keep trying. Okay? Have a good one, guys. Bye.